So now that we understand the concept of capacity and the kind of different definitions, it's similar to the flow time, where we have the actual flow time, which is a longer time, and the core flow time, which is a smaller, which is only the activities that add value, and you calculate the efficiency of that, which will be the core divided by total. The same thing for capacity, right? You have the actual throughput, that's how much you produce, and you have the capacity, right? The process capacity, and that's how much you should be producing. And you can also calculate the efficiency. You take one and divide it by the other. See, pretty easy. So that's what we're going to take a look. This is the slide explaining the actual throughput is the actual number that you're producing, or customers, or whatever it is, and the effective of core process capacity is the maximum that you can produce, right? And to calculate capacity, we're going to take a look at a little bit on bottleneck, and we're going to talk more about that, right? So uh, what you want to do is to kind of calculate, identify what is the process capacity that I can produce in a certain amount of time, and then take a look at how many you're producing to see how efficient I am in my current process. So how to do that? I can observe the process for a longer period of time. I can count how many or how long it takes until it gets to this point, or how many get to this point, and compute some average of that, right, to have the actual. So to understanding how to calculate capacity, there's different in flow time. So you have to understand the logic and the difference between flow time and capacity. For capacity calculations, we don't care about the waiting times, right? We only care about the waiting times when you're looking at the actual flow time. So you're going to take a look at the process steps and the core times that they take to calculate the process capacity. Okay, and there are many steps to calculate that. I'm going to kind of introduce you to all of them in class. We're going to do examples to see how that is, but you need to watch this video and pay attention, because you're going to try to do in class by yourself. Okay, so first step, understand the process tasks. So do process map, and then I'm going to measure the value added and the rework time for those steps. And again, there's the same way that we learned on the core flow time, how to calculate the task processing time. Usually this first one. Then and that's how it is different, right? So the first steps are the same. Actually, can usually the problems will do flow time and then capacity. After you calculated the task time, then you need to understand the resources. So the difference here is that one resource can do multiple tasks, right? And will have the task time. So you need to find out what are all the tasks that resource is going to do, right? So we have an example, I think, in a doctor's office. So we have the person at the front desk that do certain tabs, and then the nurse do other steps, and the doctor do other steps, right? So you have to find out who's doing what. And so to be able to calculate what is the total time that resource being used in each product. Okay, so you need to add multiple tasks that belongs to the same person to understand what is the total time that person is going to involve, right? So that's this thing here. I'm identifying the resources. Oh no. The resource and the task that they're being used, each task the resource being used, I'm going to add that time up, right? So, for example, one unit can do multiple steps, and then we're going to have other things that we're going to look at. One is the batch size. So sometimes I'm going to produce 10 at the same time, right? Or 20 at the same time, like the load batch that I just put the example of the cleaning clothes machine, right? So you're going to have 20 at a time. So you need to put that into calculation, because in essence, what you want to do is to calculate how much time one product takes, right? And then find out how many you can produce, right? So if a person is doing the first and the second task in the same product, you need to add them. If they're doing 10 at a time, you need to add them and divide it by 10, because they're doing batches of 10, right? So you need to figure out, in essence, the logic behind it. So kind of maybe it's going to make it more easy for you guys. I don't know. That's the logic, right? So, but I know you can do it. I know you guys are smart enough and you can do it. So we're here. So I'm going to calculate the load of that resources, how much time I'm using of that resource to produce one product. And then I'm going to add the total load here and compute the capacity for each of one of those resources. So I can have, again, okay, I have the time per nurse, but I have 10 nurses. So, or I have 5 doctors and I have 2 people at the front door, right? So you also have that another layer of complexity here because we have multiple resources that are do different tasks, right? So you have to keep that in mind as well, and that's how you do this thing. Then you're going to compute the capacity of each of those resources, and then the smallest capacity will be the capacity of the whole system, right? And we're going to talk about, remember, you guys, a little bit refresh your mind on the theory of constraints, and then voila. Well, after all that, we're going to have the resource, the capacity of the process.